Hello everyone, a very happy new year. So today we are going to discuss a problem from perturbation theory and it's came gate 2018. It's a very easy problem but little bit of tricky. So see how can we approach this problem. A one-dimensional anharmonic oscillator is treated by perturbation theory. Okay, here talking about anharmonic oscillator. The harmonic oscillator is used as the unperturbed system and the perturbation is, so this is the perturbation. Okay, so just a second. Oh, this is the perturbation 1 by 6 gamma into x cube. This is the perturbation. Using only the first order correction, the total ground state energy of the, so here mark this is total ground state energy of the anharmonic oscillator is. Okay, so here the wave function psi 0 is given and the value of alpha is also given. Okay, see how can we approach this problem. So basically here I written the delta E. How can we calculate the extra energy we got due to perturbation? So that is delta E. Delta E is nothing but energy of perturbed system minus energy of unperturbed system. So that is basically the energy we gain for the perturbation. So delta E is basically, so yeah, I use bracket notation. So if you are not familiar with bracket notations, then you can write this as integral psi 0 star, then the Hamiltonian h1. What is h1? I am going to tell. Then psi 0, and here talking about one dimensional, so that is nothing but dx. Okay, so this is this bracket notation in integral form. So what is h1? H1 is the Hamiltonian for perturbed system. So here in this question, h1, the Hamiltonian for the perturbed system, is nothing but 1 upon 6 into gamma into x cube. Okay, so this is the perturbed Hamiltonian. Here see, and psi 0 is also given, psi 0 is also given, so psi 0 is this. So see, if we are trying to solve this is nothing but integral. So what is the upper and lower limit of this integral? See, it is the harmonic oscillator problem, so the upper and lower limit is going to be infinity and 0. So that is basically 0 to infinity. And what is psi 0 star? Psi 0 star is basically the complex conjugate of psi 0. So here see, psi 0 is basically alpha by upon pi to the power 1 by 4 into e to the power minus alpha x square. So no complex term is there. So psi 0 and psi is basically same. Psi 0 star and psi 0 is basically same. So instead in psi 0 star we can write alpha upon pi to the power 1 by 4 into e to the power minus alpha x square. Okay, and what is the first order perturbed Hamiltonian? So the perturbed Hamiltonian is 1 upon 6 into gamma into x cube. And what is psi 0? Psi 0 again, uh, alpha upon pi to the power 1 by 4 into e to the power minus alpha x square and dx. See how can we solve this integral? So here the thing is, really you don't, if you are trying to solve this integral, see what happens. See, is a function of x, and see, e to the power minus alpha x square, this is a symmetric function. With respect to x, why symmetric? See, if you consider a minus x, then it's also going to be e to the power minus alpha x square. So this part, this one and this one. So this alpha by pi to the power 4, alpha by pi to the power 4. This is basically constant, 1 by 6 constant, gamma. So this is not our concern term. So we are only concerned about the e to the power minus alpha x square, x cube, and e to the power minus alpha x square. This e to the power minus alpha x square is symmetric. And what about x cube? X cube is antisymmetric. So why x cube is antisymmetric? If you consider uh, minus x, if you consider minus x in place of x, then your wave function becomes negative. So basically, this one, okay, just a second. So basically, this one is your symmetric with respect to x. This one is also symmetric, but your x cube is antisymmetric. X cube is antisymmetric. So symmetric into antisymmetric is basically leads to antisymmetric wave function, and we know the antisymmetric wave function with when by the boundary 0 to infinity is going to be 0. See what happens. So this type of perturbation 1 upon 6 into gamma x cube doesn't contribute any energy to the ground state. So delta E, the change in energy, is going to be 0. So without solving the ground state energy, you can able to do this question. Why and how? Why? Because the unperturbed energy is 0. So the energy, the total ground state energy of the anharmonic oscillator is going to be equal to the ground state energy of the harmonic oscillator. And look at the options. So here gamma by 3 is given, here gamma by 6 is given, here gamma by 12 is given. So these three options contains the perturbed function term. So but not this one. So basically from our knowledge we can choose this option as a correct one, and believe me, this is the correct option of this question. Okay guys, thank you. Please like, share and subscribe my channel.